So if you've got an expression that has n plus 3, and that's all squared, and we've got minus 100, and we want to factorize that, or we want to put it into factors, and that's squared, this will actually change to m plus 3. You can do minus 10 plus 10. Now, how does that work? How can we just like take this in? Well, first of all, there's 2 points we need to point out. It needs to be negative, and then it's the square root of this number. Why does it need to be negative, and why has it got to be square root of number? Let's look at why it needs to be negative. First of all, introducing this number, just doing the square root of that number. Well, let's look at why it's a square root. Sorry, why it's a square root is because how you're going to get that minus 100 is this by this. That's going to give you minus 100, right? But we all know that's not the only multiplication you're going to do with the n plus 3. There's also another few multiplications that we're going to do, use a distributive law to solve this. You're also going to go negative 10 times n and negative 10 times 3. That will give you negative 10n minus 30. But because this is positive over here, right, and you've got n plus 3 in both of them, that is going to basically balance it out to 0. That's going to give you plus 30. And that is going to give you 10m positive. Hence, this number always needs to be negative because you need a negative and a positive to get these cancelling out. I mean, if they were both positive in here, then you would end up with 20m and 30m, and you'd end up with all these other terms, which would change what this expression is. Because if these cancel each other out, right, you're just left with minus 100. And then the rest of the multiplication is n plus 3 squared, which is what you already had. You already had n plus 3 times by n plus 3. You already had that. So these are the final multiplications that you've got left with these. So, which would be, now you got to do your m times the 3, m times the n, because you've already done the m times the 10. Then you do this 3 times the m, and this 3 times the 3. Okay. Obviously, you don't need to do 3 times the m because you've already done that. And 10, we've already times the 10 with everything. So that will leave you still with this and the minus 100. So it needs to be minus, and that's how we can reintroduce it. So it really doesn't matter what's in here. This could be plus or minus that one. But here, this needs to be negative. And then whatever you've got out here, that will change into the square root value of c plus the square root value of c. So just a quick example, if I've got, I don't know, x plus 6, that's all squared. And then I've got, I don't know, minus 4. This is going to be x plus 6 minus 4, x plus 6 plus 4. These factors change to x plus 2, because I can combine these, right? They're like terms. X plus 10. Similarly, this would change to m minus 7. So multiplied by, this would be m plus 13. So that's where we're going with that, and that's how you can reintroduce it. Now, it needs to be negative, and hopefully you understand why, because it cancels out these terms and only leaves with this factor here. And that's how we can get to factorize an expression like that and reintroduce it back into the equation. Let's look at some other ones. So that one was an interesting question. Question 2, everyone got that one right. When we've got this one, x cubed minus x, let's fully factorize that expression. X cubed minus x. So we've got x cubed minus x. If you want to take that out, I'm going to take out, obviously, an x. And then I've got x squared minus 1, right? I've taken out the factor. This is fully factorized. When we're saying fully factorized, we don't really want to have an x squared in there, okay, if we can get rid of it. Sometimes you can, sometimes you can't. To me, this could be a difference of perfect squares. How do I know that? Because sometimes when you've got a difference of perfect squares, you'll notice one of two things. First of all, there's 0 x's in there. The other thing is one term will be positive and the other term will be negative. And then it's a difference of perfect squares if you've got that. If one term is positive, one term is negative. So that's a difference of perfect squares in there. So that's x. So now I'm just going to factorize just this is difference of perfect squares, which is going to be x minus 1, x plus 1. Now remember, similar to what I just showed you before, this negative and this positive is going to cancel out the x's, okay? Because you're going to get positive x minus 1x, which makes it 0, negative 1, and that's going to give you x squared. So that is fully factorized. Now I can just get rid of those brackets. I was just doing the square brackets just to show you I'm only working in here. That's all I was factorizing. So first thing, always the first thing you do is take out the common factor. That's always the first step you want to do. So we took out x. And then we can factorize it further in this case. Now I can get rid of these other brackets. And that would be my equation. Out of interest's sake, this would look like a cubic where we would graph it. This is things you do in year 11. Methods, what we introduce, and you do graphs like that. So that's like a year 11 standard. So something like that, you'd factorize into this, and you know your coordinates are going to be negative 1 because of this one, 0 because of this one, and positive 1 because of that one. You might be thinking, hey, don't stress. We've still got a couple more years to go. Just thought I'd show you why we do that is because it shows us where our x-intercepts are because of null factor law. Moving on. Select every expression below that has a factor of c plus 7. So what has c plus 7? Well, c squared plus 7 plus 49. Would that have a factor of it? Interesting. 49. I can see why a few people would go, oh yeah, that one looks like it has it. That one won't have it. Why? Because if you've got c squared plus 49, you can't do c plus 7, c plus 7. Why? Because if you expand this, you're going to get 7c there, and you're going to get 7c there. They're both positive. So you're going to end up with c squared plus 14c plus 49. So notice that's there. The only time you can't, if you've got this and it's a positive, this is not a difference of perfect square. You can't actually graph this. This isn't going to give you can't factorize this. Sorry, you can graph it. The graph of it's actually going to be more like something like that right at the top. But you can't factorize it. The only thing that you could factorize where you'd get a positive c plus 7 would be, it would have to be a minus 49 here, because then it's a difference of perfect squares. C minus 7, because when you've got this, now you've got minus 49, right? And then you've also got your plus c7 and minus c7, which gives you 0 c's, and then you've got your c squared. So you've got that. So it needs to be minus 49. And notice one of your factors is going to be a positive c plus 7. So the first one's not true. That one is true. This one here, that's probably more coming into some of the stuff that we're doing now. So let's have a look at that one anyway. So if we've got, what was it, c squared minus 14c. Remember, when we're factorizing these, I always look at these two terms. So obviously it needs to be c. This term's positive. So that means both these numbers need to be positive or negative, because that's how you get the multiplication. However, this is negative. That tells me that they both need to be negative. So the negative times a negative will give me the positive, and the sum of them need to be negative 14. So that would factorize to that, because that would give you negative 14c. This would give you positive 49, and that would give you c squared. So that doesn't have any factors, so that one's not right. Let's look at the last one. If it was c squared plus 14c plus 49, that would factorize into, which is what we just sort of did, this one, but let's just look at it. C, because we've got the c squared, so I know it's got to be c. C, that's going to give us c squared. It needs to be positive 49. So these are going to be either negative, both of them, or both of them positive. Because this is positive, I know they need to be positive. And the sum of both of these need to add to 14. 7 sevens, which is the factors of this, it's going to give me the multiplication of 49. 7 sevens, and it's going to give me, when you add them both together, 14c. 7c, 14c. So that one has one that has a factor. It doesn't say one, it just has a factor of it. So that one would be it too. Ooh, that was a good one. I like that one. Simplify this algebraic first by factorizing the numerator. Oh, that one's going to be a tricky one, but we could. I'm not going to get into that one, so that one's okay. Let's just skip that one. I'm not going to worry about too much. I might come back to that. We'll do this one. So the shaded area is. So what's the shaded area? Well, if you remember what a parallelogram is, remember it's just its base times its height, because if you cut this section off, it's going to go across there, so it makes a square. So base times height would be this, so it'd be m squared, because that's the base and the height. And then we've got to take away these areas. So it's m squared minus, we've got two of these areas, which is n by n. So we first have, let me just do a little snippet of this. We've got a shaded area like this. So the whole box itself will be m times m, which is m squared. So that would give me the whole area, but we need to take away these things. We need to take away 2n by n. We also need to take away this one, which is the area of that is n by 2n. So that gives me the whole area of this, including these, but then we need to take these away. So that's why, and if you think about it, they're just a rectangle, so it's length times width. So that's not squared, that will be m squared minus 2n squared minus 2n squared. This is m squared. These are like terms. Always collect your like terms before you start doing anything. 4n squared. How do I factorize this now? Well, this is still a difference of perfect squares. We've got a minus. Remember, when we look at these difference of perfect squares, I've got 0, in this case, mn's, because they're going to be multiplying by each other. And I have one positive and one negative term. So really all I need to do is the square root of this one plus the square root of that one, square root of the first term, minus, plus, minus, square root of the second term. You'll notice that that will give you positive 2nm, mn I should say, and this one will give you negative 2mn. That will give you minus 4n squared. This will give you m squared. So that is my fully factorized function. I think I answered the question. Let's check. You always got to read the question. Yep, so that would be it there. So that's a hidden difference of perfect squares. That's a very high level one. If you've got that, you're doing really well. So always the same thing. If you've got two terms and there's one that's positive and one that's negative, you can do them as a difference of perfect squares when you want to factorize them. As long as you don't have the combined term, the middle term. The middle term always needs to be missing. It needs to be none of those. So that one was a tricky one because it just had another variable as a squared number. Lastly, oh wait, I feel like we did this one. Did I start on that one? I must have started on that one. That's really bizarre. Cool. We started on this one anyway, and we brought that one back in. Let's go to this one. Complete the factorization. 7r squared minus 112t squared. So I really like these quizzes because they take it to the next level, and it helps you really consolidate it. So we've got 7r squared, and expect some questions like this on your learning cycle as well. A bit more higher order. I'm not going to give you all the simplistic ones. Here again, I've got 0 RTs. Because if you got R and you got T in here, you've got nothing in between. Like you've got no variables with the power of 1. That's another way you could look at it. These are all squared terms. And again, I have one term that's positive, and I have one term that's negative. So I've got no variables to the power of 1 in there. If you've got no variables to the power of 1, you've got none of them. So this to me is screaming DOPS, difference of perfect squares. So you got a square root, 7r. Square root of r would be r, so that would be fine. You can't square root 7. Minus square root of 112, t, so that'll be t. Square root of 112, I could probably simplify. I'll come back to that. Then I've got r, because this is positive, so this is going to stay positive in both of them. Square root of 7. Plus, because remember, you have to have a negative, so negative times a positive. Plus t square root 112. That would be your answer. I'm trying to think numbers going to 112. I know 4 goes in there. So what I'm going to do is I'm going to break this down to its prime factorization. 2 would give me, what are we at, 56. 2 would give me 23. And I'm at a prime number. So that's 4 times 23 would get me to 112. So what I can actually write this is, and this is where thirds comes in to handy. 4 times 23, always good to do your prime factorization because it really reveals all your numbers that you can get to it, because now I can square root 4. That's what I'm going to do. I'm just doing it a bit slower than what I normally would. I can square root 4. Square root of 4 would be 2, so it'll be 2 times t. So the fully factorized expression of this would be like this. That's the square root of 7 minus, sorry, r square root of 7 minus 2t square root of 23 r square root of 7 plus 2t. I'm going to go for the square root. Forgot about that. The square root of 23. And that would be your full answer. Let's see how we went on that. That's where I went wrong. Silly. So that's how you could do that. Alternatively, I did do something completely wrong. 7 goes into 100. No, 7 doesn't go into 112, does it? 7, 14. Did I not write this down right? I've done 2, 7, 14, 21, 56. Silly me. That's not 23. That's got to be 28. If that was 23, that's how you do it. Made a mistake. Let's try that again. All right. So that would actually be 28. So I've stuffed this up completely. 28. 28 goes to 4 and 7, and 4 goes to 2 and 2. So 112 is actually 2 to the power of 4 times 7. Now, if I actually got to that originally, it would have made my life a lot easier, because we've got 7r squared minus 112. Is it t squared? Yep, t squared. Because I know 7's a factor in that too, I can take out a common factor of 7. You always take out your common factors first. I was thinking that was really high ordered. I'm like, geez, this is like a year 10, like a really advanced year 10 level. If you could follow that, you did really well. That's going to give me r squared minus 2 to the power of 4 is going to be 16. 16 t squared. Oh, that is so much easier to work with, right? So, wow. Make one mistake and it makes your life so much harder. So this is a difference of perfect squares again. So it's going to be a bit easier. That's r minus 4t. R plus 4t. Not 4t, but 4t. And that is going to be a factorized answer. 7 r minus 4t, r plus 4t. Sorry about all that confusion. Hey, not a bad one to learn about though, you know, where you square root things, because all you do is you have the square root of this and the square root of that. One's negative, one's positive, and then you get your surds. However, I stuffed up my factorization. I don't know why. I think I saw it as 46, not 56. Anyway, makes sense. So you can always get to your prime factorization, and then it helps you see what common factors are in the numbers. So if it was like 14, well, 2 times 4, I could use one of the 2's there and I'll be left with 2 to the power of 3. Hope that helps. I'm going to leave it there. And yeah, good luck. Yell out if you've got any questions.